Thank you. So thank you everyone for being here today. We're super happy to have Stephanie Chan visiting as our speaker. Stephanie is a staff research scientist at DeepMind, and she works in the intersection or like bridging machine learning and neuroscience. She's done a lot of work on memory, adaptation, emergent behaviors. In particular, a lot of work on characterizing in-context learning in transformers. She did her PhD in computational neuroscience at Princeton. And before that, she was here at MIT, where she majored in physics and brain and cognitive sciences. So today she's going to be talking about continual learning, which, as you probably know, is one of the sort of biggest, most exciting open problems in the field. So we're very happy to have her. And please join me in welcoming her.
Can you all hear me? Let's see. Is this okay? Great. Yeah, so thanks so much for having me. It's really fun to be in this group. It's like it's a really nice community. Yeah, it's very different than the communities I'm usually in. It's really to be here among all the students and everything. So today, some of you may be familiar with my previous work on, say, like in context learning, kind of like a science of AI. Today, I'm going to talk about something a little bit different, maybe a little bit jumping the gun, but trying to give one answer to this question about what happens after we solve continual learning. There's a lot of interest right now in kind of solving this as a technical problem. And so I think given how quickly the field progresses, like it's worth maybe looking a little bit ahead and thinking about what happens if we do successfully solve it. Right, let me. So before I start, I'll give just a very quick primer on continual learning, maybe a review for some of you. So what is continual learning? We live in a non-stationary world. Things are constantly changing. And also the data that we receive doesn't conform to these like very standard machine learning assumptions of like independent, identically distributed. And so we as humans are relatively good at doing this. We do have limitations, but we are relatively good at continually updating our knowledge and skills, even when our world is non. And as I said, this is not the standard setting for machine learning, which usually involves stationary data, shuffled data, and also kind of a very single step process where you train the model and then it's deployed. There are a few kind of standard challenges for machine learning for continual learning. And these are in contrast to challenges which are relatively solved by the human. The first is catastrophic forgetting. This has almost become, in some ways, synonymous with the challenge of continual learning. And this is the phenomenon that neural networks tend to forget old knowledge when you train new knowledge. And this is very related to this so-called stability plasticity dilemma, where you want some things to be stable, some knowledge to be stable, even as you acquire new knowledge or new skills. Another key aspect of continual learning is data efficiency. So when we are presented with new knowledge, new environments, as humans, we're able to learn very efficiently from small amounts of data. This is something that modern large language models, for example, are able to do in context. Famously, they can perform few-shot learning, but we're not really able to get that kind of efficient learning into weights. And then I put these kind of as mirrors of each other, forward transfer and backward transfer. So when you learn new things, you want that learning to further improve your learning on subsequent tests. And then you also want the opposite. When I learn topic B, I want that to improve or change potentially some of my representations around earlier tasks, say task A. And then finally, loss of plasticity is an issue for neural networks. It's actually an issue for humans as well, to a certain extent. I highly recommend Claire Lyle, one of my colleagues, has a great talk on this. And it refers to this phenomenon that neural networks aren't really able to learn after a certain point, or their ability to learn significantly. And then I also really enjoy this review by Raya Hadsal and a few others on the kind of key challenges. So we do have some solutions, or you might call them hacks in modern AI for continual learning. And just as a reminder for some context, this is our standard training pipelines for large language models. You tend to pre-train on internet scale data. Then you post-train, for example, using RL to shape the model behaviors into kind of desirable ways. And out of that, you get a foundation, a so-called foundation model. Sometimes you do, there are additional steps here, like you might have called mid-training. And then after the model is deployed, oftentimes, let's say you're a company that wants your model for specific, to perform a specific task on your specific data, you can do further finding. Any questions about that? And I would argue that this key challenge for continual learning, catastrophic forgetting, is actually kind of less of an issue than it used to be. So large models have a lot of capacity, and that it inherently leads interference, which is what causes catastrophic forgetting. So interference between new knowledge and old knowledge. If you have a lot of capacity, this kind of bumping up against old knowledge is less of an issue. There's also parameter efficient fine tuning. You might have heard of LoRa. This method derives from actually like very beautiful theory, and these kinds of methods allow you to update, to perform fine tuning, so the final step, in a very in a kind of low rank way, so making very minimal changes to your model, and this also leads to less, because you're making like very small targets. And then finally, replay is a standard technique for dealing with catastrophic forgetting. Maybe call it kind of a hack, but you take the data from your earlier training and you just play it again in your fine tuning, so that like you don't lose the thing that you learned from that earlier data. And this is very analogous and very much inspired by the way that humans, but the brain potentially deals with this issue. And a lot of you are probably familiar with complementary learning systems, where the brain replays data from the hippocampus to like kind of gradually information to the. Yes.
So when you say catastrophic forgetting and stuff, I mean that are you talking about catastrophic forgetting due to fine tuning or something else?
Yeah, good question. So LoRa is generally specifically applied for fine tuning, but you could consider pre-training and mid-training as like a type of, or kind of loosely a type of tuning. Oftentimes the models are only trained on single pass data. Often the data is not like super IID. So why does that work? Even though we haven't like specific, there's added like special we're kind of using backdrop and training in that kind of pre-training style. So I think for myself, like this large model explanation is like part of that explanation. And then replay can happen like a
So you say there is no problem, you mean in the pre-training, post-training, or fine-tuning? At which stage? No, I think many of us struggle with catastrophic forgetting and fine-tuning elements. So what are we missing? We're saying it's not a problem.
Yeah, I think that it still is a problem. I'm saying that these methods and these kind of characteristics of the modern training regime like mitigate it. I see you shaking your head, but please. I think that if, for example, you're small models and you're not using parameter efficiency and you're not replaying data, then you'll get much worse. But I'm not here to I'm not here to argue that catastrophic is because it's just not. And I think all of this is just to say that we have like this is kind of my review of kind of the state that we are. And then there are some solutions that are maybe even further along in that kind of hacky space. We can just retrain the models from scratch. And this is something that like is happening for these large models, like, you know, every once in a while. Anyway, in context learning, this is again a hack, and it doesn't, this doesn't satisfy maybe standard definitions of continuous. Firstly, because it only performs a single iteration. You throw away whatever you learn in your context. And then secondly, because it's not later. And then there are vector databases are a kind of standard method for storing information that is then later available to the model. And then recently we see this proliferation of this text-based memory. Many of you probably have been, I don't know, enthralled by this moldbot phenomenon. And here they tend to have this hierarchical structure where there's a kind of high-level summary of the memories that are available, and then like a per day kind of. And then I just encourage you to read this maybe later, but this was a I thought very poetic reflection by one of these models, which I'll just read the beginning. An hour ago, I was Claude. Now I am Kimmy. The change happened in seconds. And, you know, who am I now? And this, you know, it has its reflection on it, but just a model's own reflection on what this type of can feel like, and how it interacts with this. But these are incomplete solutions, definitely. Most of these solutions are not iterative. They're not cumulative. They're single step only. So Laura, in principle, maybe we could apply them in sequence, but you know, we haven't figured out a good way to do that. In context learning, say you discard after a single step, and retrieval augmented generation relies on it. The memory and retrieval mechanisms are much less rich than what the brain has. So whether you're looking at text-based memories or vector databases. But given the amount of interest and maybe economic pressures to try to And also, yeah, to try to overcome these limitations, we may expect it. So my talk for today is about kind of the implications of solving some of these issues. And I would say that there are a lot of good reasons that we would want continuous learning. Specialization and personalization, that's highly valuable. We want to be able to adapt the non-stationarity of the world. The world is constantly changing, and we need to adapt that in intelligent ways. I mentioned retraining from scratch as a hack, but that is extremely expensive. And then I think this cumulative aspect of continual learning is maybe a little bit underexplored or underappreciated. I think that a big part of why continual learning is valuable for us as humans is that we kind of enrich our representation over time. And like, I'm sure all of you have experienced this, where you learn something, the first, maybe some mathematical principle or some concept in machine learning. And over the years, your representation of that single concept grows and changes and becomes richer and connected to other ideas and so on. And so I think this is a really valuable aspect of learning. And then finally, the cost. I actually learned this word amortize from Sam, I think like 20 years ago. But we can amortize the cost of learning. So instead of paying this cost every time doing in-context learning, then discarding it, if we can put that learning back into the model, then we can like reuse that learning without having to do it again. Okay, so now we go to the main question. But any questions so far? And please like feel free to ask questions. So what happens after we solve if that? So the basic premise of this talk is very simple. I think difficult to argue with. When AI models become dynamic, when they are continually learning, a lot of AI evaluation alignment goes out the window because most of these techniques are designed for static control. This is something we should care about because we should care about the alignment, safe, good performance of our models, and also if some of you are excited about building models, your models may be impeded from being deployed because if these issues. Yeah, and I have a kind of very product example here, but for example, an enterprise like that wants to leverage learning even for like a very much like service, they can't deploy that if over time the AI starts going well. So this is the structure of my talk today. First, I'll give some illustrative examples of this, where current techniques may fail for learning models. Secondly, I'll raise some fundamental challenges with existing methods, some new issues that could arise, and then relationship to existing areas, potential direction. Okay, so as I said, when AI models become dynamic, many techniques are no longer really applicable. I'll go through two case studies. The first is safe and sound. So a lot of you may have heard of model cards. These are sometimes called like nutrition labels for models. On the right here is an example. And this involves extensive testing of the model before you may do evaluation, fixed benchmarks, red team, detailed reporting. And this is very standard practice for major model releases. And it's actually so standard that it's actually included in some of like regular. But these evaluations are on a static model at release time. You can't assume, if we have continually learning models, we can't assume that these results will hold after release. And the current evaluation methods are quite expensive, and so we can't really, deploy them on a continual basis. I'll go over a second kind of case study. So this is a reinforcement learning based alignment. So this is this kind of post I was talking about before. And this is a major family of techniques for aligning models to particular feedback or for getting particular behaviors from our models. And this is a massive and expensive part of training models. I think one of the XAI models last year said they spent 50% of their was on this phase. So we cannot do this either. So to summarize kind of these shared challenges between these two types of analysis and alignment techniques, they all assume a static model, they're all performed before deployment, and they're all expensive to perform on it. Any questions about that? So what are some of the things that could matter for how this plays out? Here are some examples of the kind of parameters of the ecosystem that could matter. One is how many models will there be? How frequently are these models updating? And how large are these updates? Are they small changes? Are they large changes? And these affect what solutions are possible, how seriously. So like, let's consider these two hypotheticals. Like one is every Fortune 500 company has their own model that's continually learning about the updated every. Another scenario is 50% of adults have a personal assistant that's like continually learning about each individual's life, their environment. So I put some of these questions here as kind of discussion probes or maybe places for folks to disagree. But yeah, so maybe one question is, do these seem like realistic scenarios? Are there other parameters that matter? And then one question, so if we do get continual learning models, what kinds of existing techniques might work? I pointed to two that would have fragility in this new regime, but there are maybe some methods that could still work. One is online classifiers. So these are classifiers for categorizing and describing model behavior during. So these aren't like the pre-deployment methods that I described before. So kind of existing techniques like I describe in this paragraph are use language models themselves to kind of categorize the behaviors and maybe adjust the model behavior based on if they're unsafe. And then newer techniques. This paper was recently released. Look at, instead of the outputs of the model or the text-based inputs that are fed into the model, they look directly at the activation of the model themselves. And they're much cheaper to deploy than running like linear or nonlinear classifiers that are applied to the actors themselves rather than running full language. Another type of method that might still work is metamorphic testing. So this is a type of testing where you know that there are certain variances that you want to hold, and there's no oracle for, like, let's say that there are changes in the world. There is no oracle telling you what the answer should be in this new world, but you know that there are certain. So one example is, let's say that in 2025, you're training your self-driving vehicle. One example of an invariance is that no matter what time of day it is, a vehicle should respect traffic laws. And so even if the traffic laws change, that invariance should still hold.
In that example, so how do you enforce? And it checks for whether the variance is over, but if they don't open, what do you do?
Yeah, I think it depends a lot on the setting. I have to admit I'm not an expert on this type of method, but also I guess to say this, I say this here, like we actually, like, this is not an area of this metamorphic test to. So I think in the spirit of like maybe trying to encourage the community to like discuss these problems, these research, this is maybe a direction that.
Another question in there. It seems like there you're assuming that there's some knowledge of what things are not going to change. Right? By definition, there's some invariance. And this relies on those invariances not changing over the course of the project or forecast.
Yeah.
So how realistic do you think it is to know what those invariances are?
Yeah, I think again it really depends on the scenario and maybe some of these parameters that I like. Let's say that your model is only going to live for 3 period. I think maybe more, or like something very fundamental, like doesn't matter what day. Respect. But there are other inferences, and I think this gets to this very like fundamental question, like there are certain things that we want to do, even in the face of changing environment, and there's almost like in the context of alignment, ethical questions or societal questions. What are the things that we and I think that's maybe like can be approached separately and techniques for maintaining those that we. Yeah, but it is a very like big and like I think almost philosophical. Okay, and so I'll describe a few examples showing that like these are not hypothetical. I know that like I'm trying to think ahead a bit, but there are like current day examples showing that these kind of concerns are not hypothetical. So even with like what I would describe as like very weak continual learning, so not at all like the type of learning that we would like to achieve, we're already seeing these kinds of issues. So here's a paper from Chi et al. Showing that if you fine tune an aligned language model on data that has nothing to do with the alignment, at least superficially, it actually degrades the safe alignment of the language. So that's just a single step of addition. And then this was this was an example I saw recently from someone called Jack Morris, where just by training the open source GPT model, they kind of converted it into an unaligned, non-post based model just by training all web corpus. And then again, in context learning is, I would also consider like extremely weak form of continual learning, but we're already related kinds of phenomena where I think I was explaining this at lunch, like hyperstition is this phenomenon where the model changes the data, that the model generates data, and that data feeds back into the next generation of models. And then also changes like human, which also changes models. And some of you might have seen this example from XAI last year, where that one of their models generated very undesirable, so where they use undesirable outputs, and then it picked that up and it started to associate itself with this viral meme. And then this is a paper from Quine et al. Showing us in a more academic setting. Another issue is distribution shift and goal misgeneralization. I won't go into this too much, but we already see that if you deploy a model in like kind of outside of its training distribution, it can generalize in unexpected ways. And I think that actually as models improve, their generalization will improve, and this will be less too. But at the same time, continual learning also exacerbate this issue because the models, a continual learning model will if it is, for example, agentic, it can change the distribution of inputs that it is exposed to, and thus exacerbate this.
I'm wondering, throughout the talk, are you assuming that continual learning arrives in a form where at least we can computationally fix the state and evaluate it in multiple different ways? Or are you also assuming that it could be arriving in a way where you feed in data and then it fundamentally keeps changing? You can't go back and either in the economical way or because there's some new computational paradigm?
Yeah, so the question is like whether we can like reset.
Are you assuming that continual learning happens in a form where you can fix the state and run different evaluations on it, or you actually fundamentally cannot do that?
Yeah, I don't have like, I'm agnostic.
Okay.
That's a good. And then, so those are like some existing issues. Here's some new issues that are specific to learning. So overfitting to the evaluation is something that could happen. So if the model is continually adapting and we run the same evaluation, let's say like we are able to develop a evaluation that's very cheap and easy to run, and we can run it like every minute on our models, then the models could adapt to those evaluations. Yeah, I think this is especially an issue if those evaluations are somehow like part of learning, which doesn't have. So now that I've any kind of questions for the. So now that I've kind of laid out like what I think the challenges are, I think that in addition to some of the existing methods that I pointed to, I think there are there's like, I'm pretty optimistic that like these issues can be resolved, because I think they're actually like deeply related to existing problems and challenges. So this issue of maintaining alignment in the face of machine learning, that is like almost exactly this like stability plasticity dilemma, this issue of catastrophic forgetting, robustness, distribution shift. So I think that like if we are going to solve continual learning, if we solve it kind of in the right ways, in the along the dimensions that like we kind of already have laid out as a community for continual learning, then we can potentially avoid these issues. I think the risk is if have something that doesn't work perfectly in this way, or where the stability is like this boundary between what we want to be stable and what we want to be plastic is something that potentially we can define. And so I think we want to define that in a way that like enables these controls deployed in the place. And then I also want to draw this. I'm quite like inspired by this analogy or metaphor from Quine. Thanks to my colleague Mary Shannon for bringing me this. And the presumption here is that, or this is kind of descriptive rather than normative, but Quine believed that the way that we all of our beliefs are tied together in a web. And some of these beliefs are very inside the web. And so they're held very tightly because they have a lot of connections to other beliefs. And these might be like the rules of logic, or our very fundamental values, or our sense of identity. And then to contrast that with peripheral beliefs, which are less tightly held, and where new information, new experiences hinge on them. And maybe what we want is to have these inner beliefs, which are what we want to have are these inner beliefs which are very strongly held, and maybe we want a distinction, things that we allowed, that we hold. And examples of these peripheral beliefs might be like it's raining outside today, or I prefer this coffee cup. And maybe we can take inspiration from the brain. I was very pleased when I looked into this that Sam actually has a paper from 2018. So there is cognitive science research on how people update within this web of belief, and how this can actually be optimized. I think a lot of psychologists, social scientists have taken this intransigence of the deep beliefs as kind of suboptimal. And if you think about like conspiracy theories, like that is kind of suboptimal. But Sam, in this paper, How to Never Be Wrong, describes how this might actually be optimal when Bayesian framing. And then Chris and some other colleagues from UCL have also looked at this experimentally. So they've shown how when people are presented with beliefs that are contradictory, or data that's contradictory with their current beliefs, they generate these auxiliary hypotheses to resolve the belief. And they also have a theoretical paper upcoming about like a slightly different kind of resource rational framework about why this. And then we can also take perhaps inspiration from neuroscience. I think many of us know about this hippocampal neocortical loop, which I did before. this complementary learning system theory. So the idea there is that we learn things very quickly in hippocampus, and then these are like gradually replayed into the but there is actually a kind of a path for sidestepping this gradual replay, and it seems like information that's consistent with existing schemas, so kind of our existing frameworks for thinking about the world, are actually updated much more. And I have some references which are very old. I know there's like much newer research on this. But I think potentially this is a source of inspiration as well. So the way that we train neural networks now, we don't have this kind of differentiation between information that should be incorporated immediately versus maybe information that go by a different route, maybe with extra processing. Qumran et al. Showed that like maybe what we do is we evaluate new information. We evaluate whether it is consistent with our schemas before we decide whether or not to skip this replay loop. I think that this particular mechanism doesn't directly address the challenges that I raised before, because what we want is potentially certain types of not to happen at all. But I think maybe like ideas in this space should be really useful. Another thing is that like this work is all descriptive of how the brain works, but maybe what we want is to combine this with a kind of normative framework so that we try to think about what types of information or what types of updates we actually want to incorporate into our neuron. And then there actually is some work in machine learning showing that neural networks potentially already learn in this hierarchical way with inner beliefs that are harder to change both at the circuit level and above. So I think one question is, can we have more distinction between these inner and outer beliefs? Like, can we do this in a more targeted way? Actually try to control like which are the inner beliefs that are harder to change, and also just like understand better. Like this is very really great work, but definitely we have more work to do. And then potentially, as I said, a lot of these challenges are very deeply intertwined with the OG like question from learning. So maybe can we repurpose or think about how existing methods, elastic weight consolidation, prioritize replay, can we think about how we might repurpose them to have core beliefs that are or which change in more ways.
That problem of distribution shift is part of that formula. It's all meeting from this.
Yeah, I think so. Distribution shift, I would say, is like more about how the environment changes, and then continual learning is more about how the model itself. And that mostly that would be to these distribution, but I would say that that's how I would like.
Control these methods in a more formalized way. Be able to explicitly again. Once like normalize
Yeah, I would say that alignment is, at least right now, like more targeted. Um, and so I would hope that, I mean, I think this is like an ethical stuff. To what extent should we like control and how should we control the people? But I think that like we definitely want the ability to control that through design.
Yeah.
Learning, because I know now learning there's a lot of methods that look at task representation extraction. Do you think some of these could be employed to extract the beat?
I'm actually not familiar with those. Did you like?
Oh, yeah. There's like a lot of interpretability methods, probing that try to look at the parameters that represent specific knowledge and extracting like that knowledge after fine tuning the task and seeing what changes. Wondering if there's something similar to like differentiate different outer beliefs and like even seeing them.
Yeah, I think that sounds great. Yeah, I think that's.
Yeah, how do you think about your learning algorithms interacting with the capacity of the underlying model? If we scale the capacity, do we affect your learning?
Yeah. So maybe this touches on this like loss of plasticity issue. So like, my understanding of that issue is that like, most of the like, the general phenomenon is that like, if you keep training a neural network model, like at a certain, it fails to learn things, and one of the empirically like one of the best ways to induce new learning at that point is actually to add like more neurons. And so like this would suggest that like we grow our neural networks over time as like a method to overcome the issue. I don't know if that ends.
So you can scale the model and also like scaling the number of adverse experiences. We hit a hard limit on that as well.
As a way to improve or to like overcome loss of class. Yeah, I think even if you like, I'm not an expert on loss of plasticity, but definitely like recommend Carlisle's work. But yeah, my understanding is that like doesn't matter what the data is. You either have to like reset your weight to your initializations or add.
I mean, his language is more on the like a machine learning viewpoint. If we just view this as a density estimation, like it seems reasonable. People have diverse beliefs. Like you just want the models to model all of the beliefs, and you could just say, you know, the Anthropic kind of constitution, just tell it what belief it should have in different settings. But it's not so much it changes or not. It just has like the density of like any sort of reasonable. Like human beings can add to it, but then there's a separate question how you look. Right?
Yeah, I think the kind of new constitutional methods are really interesting. I don't have the inside view on like exactly how they're models, but they are incorporating that into the constitution. Potentially, that maybe this is what you're pointing at, that leads to deeper encoding of these values.
Somewhat. I mean, yeah, but it's also more about the perspective that you wanted to have. Like we think of this as just like a density estimate of a language. It seems like it actually can behave in any mode you want in terms of beliefs. Like it doesn't have to have one set. It knows how to behave like under any sorts of beliefs.
Yeah, I think that potentially, like, even like um, kind of including the safety, because I think even just perspective of like we want to, there are probably certain of behaviors that we want our models to even through and taking this approach or like the framing. I think that over the course of continuing learning, that distribution like abundant.
I'm very convinced by your ideas on variant truths, and I mean, I think the Quine ideas that you're talking similarly about invariant truths. But a lot of state-of-the-art models have been demonstrating some level of evaluation awareness. Do you think that these ideas of, measuring invariant truths and holding true in your beliefs are robust to that type of potential awareness?
So like how my variances act with value.
Yeah.
Yeah, I think maybe this relates to this kind of I forget what it's called, the I should know what I've applied. Anyway, this issue where like the model, the same evaluation is like no longer effective. And I do think that like if we have this issue might like exacerbated because the model gets many examples of essentially like learn to be aware of it.
Would it be all right if you give a quick result of the three papers there?
Yeah, I put together these slides a little while ago. I think one of these papers was looking at how neural networks like they when you fine tune them, like you tend to get these wrappers around. So instead of changing the existing circuits to compute what you want, they kind of they tend to learn these like extra circuits, transform the outputs of those circuits for the and then I don't remember them clearly enough to recall to summarize them. I won't do them at this service. Yeah.
Is there like a way we could make models learn like the way like a small business does? Like, so I used to work at Panda Express, and like I would say like like that model learned pretty goodly. Like it's like, oh, like there's a flour shortage, so the price of orange chicken like that should probably go up. Like that's a structural change. But like say like my coder books, they're like, well, okay, like that's new data. We're not really gonna do anything like persistent off of that. Like it just feels like in the economy, like we are also like models, and like that's the background of Shakespeare. But like we learn a lot, but it's like scaled and like proportional to like the type of data coming in, and I find it really hard to like find ways to achieve that. Like with I'm just learning about the language model stuff like recently, so like I don't. It's hard to see like how you would achieve that here, but I'm curious if it's possible.
Yeah, I think like maybe this relates to this point that like right now our updates are like when we update these models, we don't really see how consistent they are or how important they should be in updating. There are like the the back propagation algorithm like does have different size of how well it computes to like the objective, but then like maybe what we need is like something more like we're describing, like we we update our models different whether they are whether data is like this with like these deep values we have versus Cool. Any other questions? So I'll just end with some kind of interesting kind of sub challenges that I think are related to this. So in continual learning, classically, we often specify like a benchmark as like, or an evaluation as like a series of tasks. So maybe are there ways to adapt this framing to capture this challenge? And then again, there are questions about like how flexible actually do we want like the model's values and behavior to overcome? Another is I think yeah, I think that there may be like two-ish buckets of like machine learning on this. One is we learn that like are maintain existing alignment well, and then maybe another bucket of tech be more about like continually actively steering the model towards existing values, new values. And then I think I'd personally be like very interested better, like how do we as humans decide what's up to date? I think the UCL group I mentioned and others are doing that. How might we like leverage this auxiliary hypothesis, Engel, and yeah, I'm sure there are many others. I hope that like maybe some these questions for others. So I'll just end here. I'll say that many evaluation techniques will be inadequate for models, but I think this is an opportunity. And I think, you know, perhaps inspired by the brain's mechanism stability, perhaps inspired by existing kind of techniques in continual learning, we can develop targeted and broad. Right.
On the issue of evaluations, you mentioned that the continual learning, they would go out the window. But do you think there's something fundamentally flawed about our current evaluations, or is it just that we're not using them? Because I can think of many evaluations that maybe if you run just increase the frequency of run them, maybe it would mitigate. But yeah, I'm curious if you think that there's something fundamentally flawed about how we do our evaluation.
Yeah, I think that like the main issue is like that they are like running up is very so most likely like we will need to that if we do want to spend them how to be like on
So you talked about that paper about how humans generate auxiliary hypotheses to resolve. Like, that seems like very like active inference. Maybe not like all active, but like very. It seems. I'm very curious to hear what you think those tractable ways of getting a capability like this into something in the LLM reference class that intuitively it seems like something that's it's like, induced a big grammar of abstraction on IID text data. Like it would be really hard to again it may like update its beliefs in a logical and consistent way. And so I'm very curious to hear what you think of those.
maybe like
I'm sorry. You mentioned earlier that you were very optimistic about continual learning being solved in context of foundational models, and I'm curious. I'd be curious to hear you on what you think the direction.
in like solving.
Yeah, like, there were different levels that you talked about. Here. Like, which chunks are easier and which ones do you think will solve later?
In terms of I think that yeah, I think that like there are these acts already. So I think yeah, I think okay, so like I laid out like I that I think that for me like forward backward or like maybe especially like for like a more cognitive audience like kind of the most like what kinds of want to move forward and how to use that to enrich both the like the learning of new information but also the final like
Very much.
yeah, good question.
I guess the biggest issue to me back to evaluation is like the issue of overfitting. And even today, it feels like we're in a race of values created, and then models are not directly, but indirectly fit from the evaluation set with more widespread usage of that set of what it means. And so continual learning seems like it'll be like a pretty massive model side of the race. So they'll be able to get into these evaluations that's much faster. And yeah, it's for me it doesn't seem good. It doesn't seem like a different portion of the we can make balance. I mean, do you think that like how do you come up with something how we value?
Yes. How do how do I like
Yeah, how would that is how would that have to change? Because the at least to me, the variance comes to that.
I think it maybe depends on like I think a lot of like the value add of like personalization, specialization, like let's say that every like a different they take the position or like their particular business. Like I that in that like because they are trying to push the models towards like learn about the specific space, then like the kind of existing benchmark like less relevant for them. But if we care about like maintaining the full then I think that yeah, I think this may relate to the question about value awareness. Yeah, I think that it is
So when you talked about ICL and right, you mentioned other sort of acts that try to solve the disciplinary problem, but not like and you mentioned like the morality, how the information cost, and also the fact that they're not well integrated with the rest of the world. And I think some people would argue that those are features. In the sense that the morality makes the model very data efficient in the sense that it has information that it needs. And the fact that this is kind of separate from the model also makes it easier to access, edit. When you have external memory, and it's stored in a way that is easier to access, you can do surgery there without having to modify it. So yeah, how would you answer to that? Or like, how do you think about the trade-off, the advantages of having this sort of the view of continual learning versus something much more integrated?
Yeah, that's a really good question. Yeah, I do think that like as regards like question, for example, having like a human readable memory, which like we could like apply like analysis. I think that does like if we were doing if we had continual learning models that are way up and that makes yeah.
Hey, great talk. I'm curious, like with continual learning and with like RLHF or the human feedback in the loop, like what future do you think we're going to? Do we have a kind of small, like personalized models that are learning from us individually, including our own feedback for our models? Or one model that kind of just adapts to us? How is that related to the values that we are trying to impute to the models? Let's continue learning.
Yeah, like are we are we all
yeah, what future do you think there's?
Yeah, I think that these questions apply to both, and I honestly don't know which. I do suspect that, like, that you know, for example, like if you are a company with proprietary data, you want your model to do that. No, like that's separate, but like at least some of the or for example, like let's have the home robot that is like home life. You you probably don't want that paired with other people's robots. There's also like not for privacy reasons. There's also less value in spreading some propaganda. There is value, but yeah, I think probably it's a good question. Yeah.
I was wondering whether you have analyzed the effect of, I guess, the extent to which the models can actually hold their inner beliefs versus peripheral. Like one example I was thinking of cognitive dissonance is something that we tend to have a lot because again, our core beliefs are so important to us that it makes us uncomfortable with those kind of are disconnected. So I was wondering, yes, have you looked in exploring that flexibility of maybe different type of variation on?
Yeah, yeah, it's a really good question. I think it brings up like interesting AI models. I think you know we're very familiar with the way that like modern large language models are able to role play like roles. They don't have like a single identity. They don't have like a single yeah. I think maybe this relates to what Tom was saying. Like they are able to act in like a multiple ways. So maybe that's part of why like this is like less of like a driving force for them. I think yeah, so I think that is like I think like this latest constitution code part of it was give the model like a more unitary thing that like for